Here's an example of algebraically finding the angle in between two vectors. These two vectors are given in component form. We could also write these two vectors as position vectors, being just the 2 component, the -1 is the j component, and +1 is the k component. The b vector can also be written, I often call this pointy bracket notation, as 3, 2, -1. These are two separate notations. They should not be mixed up, but you do have the option of writing it either way. I honestly prefer pointy bracket notation a little bit because it just seems a little bit cleaner. So let's recall the theorem that gives us the angle in between two vectors, which is that the cosine of the angle in between is given by the dot product, A dot B, divided by mag A, mag B, magnitude A, magnitude B. And so we need to find all three of these quantities. So we'll start off by finding the dot product between two vectors. So the dot product between A and B is going to be our x components multiplied together. Now these are scalar multiplications, so I'm not doing a heavy dot like I would if it were the dot product between two vectors. So scalar multiplication plus the y component, -1 times the y component 2, plus the z component, +1, scalar multiplication times the z component, -1. So we get that the dot product between these two vectors is going to be 6 minus 2 minus 1, which is going to be 3. So there's our dot product. Now we need to also find the magnitude of A and the magnitude of B. The magnitude formula is that we are going to take the square root of the components squared and add them together. So for mag A, we get the square root of 4 plus 1 again, which is the square root of 6. For the magnitude of B, we're going to square all of its components and add them together. So that's going to give us the square root of 9 plus 4 plus 1, which is the square root of 14. So now we are going to take all these quantities and put them into the formula again. So the cosine of the angle theta is the dot product of the two vectors, which we turned out to be 3. The magnitude of A was rad 6. The magnitude of B was rad 14. All those are scalar quantities. And so now we're basically going to take the inverse cosine of that scalar. So let's call this underneath here the square root of 84. And we'll take the inverse cosine of that in our calculator to get the angle in between the two vectors. Now let's recall from trigonometry that the inverse cosine is a function whose output is only going to be in the first or the second quadrant, but that's exactly where we want our angle to be in the first place, right? Remember that the angle in between two vectors has to be somewhere between 0 and 180 degrees. We do need to be careful when we're taking inverse trig functions, but in this case, that's going to give us an output that is precisely in the right quadrants that we are allowed to be in. So now let's come over to our TI calculator, and I'm going to get this angle in degrees. So let's come over here and then say the inverse cosine of 3 divided by the square root of 84, and we'll see what this angle gives us. So we get 70.89 degrees, and that is going to be the angle in between the two vectors that we had initially.